One of the topics you have to know for probability is how you find a sample space. So one of the easiest ways of working out your sample space is to use tree diagrams. So in terms of tree diagrams, you're carrying out a series of steps and it will tell you the results. So you're mimicking some job or doing several jobs. Okay, it'll make sense in a second. In terms of tree diagrams, write the outcomes out at the end of each branch. Write the probabilities out along each branch. Don't simplify fractions. Each branch fork will add up to 1. And the end of all branches will add up to 1. And how you find the probability out for the end of the branch is you multiply along the branch, right? And that should make sense as I explain in a minute. So, if you look at this tree diagram I've already done out, what this represents is I'm throwing a coin 3 times. Okay, it could be the same coin 3 times. So this is my start point and I'm throwing the coin. When I throw the coin, I get 2 answers. I can get a head or a tail. So they are my answers. Then I throw the coin again and I will get a second set of answers. Then I will throw the coin again and I get a third set of answers. Right? So each time my answers are only a head or a tail. In terms of probability, this and this, so the fork of my tree have to add up the same thing. If it's an unbiased coin, you would assume that is a half. And that is a half. Okay? And as you go on, you're doing exactly the same. So this would be a half, and this would be a half at this point. Again, a half, and a half, and again, a half, a half, a half, and so on all the way along. So every time you're throwing the coin, you have half the chance of getting a head, half the chance of getting a tail. In terms of outcomes or sample space, you imagine going from your start point out to the end of a branch. So you'd write down the outcomes. So if I got to this leaf of the tree, right, how I would have got there is I would have gone H, H, H. So my sample space would have said H, H, H. To get to this one, I would have gone H, H, T. So I went from here to here to here. Next one, you're going H, T, H. Then you've got H, T, T. And then we're on the second or the lower half of the tree. So we go T, H, H. T, H, T. T, T, H. And T, T, T. So from this, I have 8 leaves on the tree, right? So I will have 8 outcomes in my sample space. Okay? So again, in terms of outcomes or sample space, you follow the branches and write down what you got at the end. And probability, each fork has to add up to 1. And for you to get the probability at the end, if you're working along a branch, you would multiply the probabilities. So if I wanted to work out the probability I got to this leaf up here, coming along that route, I would have gone a half times a half times a half. So when I'm multiplying, 1 times 1 times 1 would have given me 1, and 2 times 2 times 2 would have given me 8. So my probability of getting this answer would have been 1/8. Right? In terms of this tree diagram, because I have equal chance of getting heads and tails, I could also have read that probability by simply counting the number of leaves at the end, which is 8, and saying how likely was I to get this one, so it's 1/8. Right? Another example, for example, I could say I had bags of counters, and my first bag, so this would represent the first bag. The first bag, I had 7 counters in it, and there was some red and there was some blue. The probability of getting a red counter was 3/7. So my probability of getting a blue counter is what's left. So if I have 3/7 here, the probability down for your blue is 4/7 because each branch has to add up to 1. My second bag, I have red and blue counters in it again, but this time there's only 5 counters in the bag. So my red was 2/5, so my blue would be 3 over 5. This point here is meant to mimic the exact same as this, so the probabilities on these two branches will represent or mimic these two. So for my red, I have 2 over 5. For my blue, I have 3 over 5. And then my third bag is here. And in my third bag, I have two different colored counters, O's and B's. So I could say red and black this time, but I've got 6 counters in it, and one of them is red. So that means 5 of them have to be your black. So you go 5 over 6. And again, for each of these branches, you mimic the exact same as up here. So you'll have 1 over 6, 5 over 6, 1 over 6, 5 over 6, 1 over 6, and 5 over 6. The outcomes from this tree are how you get to the end of the branch. So you would have had an or, an or, B, or B, or B, B. So that's these 4. And then the bottom half, we've got a B, or, B, or, B, 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 or, and a B, B, B. So when I count, I have 1, 2, 3, 4, 5, 6, 7, 8 leaves. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 sample spaces. If I had to find out the probability of me getting a particular thing, so if I wanted to predict the probability of getting a red, followed by a red, followed by a red, if I look at my tree, the only diagram I'm getting a red, red, red is this route. Right? But the probabilities change every time, so I cannot just write down 1 over 8. Okay? My probability for a red followed by red followed by a red would be 3 over 7, which was the first probability, times 2 over 5, times 1 over 6. And in terms of multiplying that out, you go top by top, which will give you 6 on the top. And on the bottom, you have 30 by 7, which is 210. All right, so the probability of me getting 3 reds would be 6 out of 210, which means a pretty low average. If I wanted to find out the probability of getting 2 blues, or 2 ors. So probability of 2 ors, and they could be any order. Right, if I look along my outcomes, 2 ors means I could have done it this way, this way, this way, or technically that way. Right? So for that, you would have to work out the probabilities for each. So you would go probability of or, plus the probability of or, B. So your probability of or, B would be equal to probability your or, which was 3 over 7, your or, which was 2 over 5, but then your B, which was 5 over 6. So in that case, you are getting 6 times 5, which is 30 over 210. Right? In terms of this, every leaf on the last row should end up being over 210. So that's why I'm saying don't change your fractions into decimals. And when you would have calculated all of these, they should add up to 210 over 210. Okay, but you would work out the or, B. You would work out the or, B, or. And you'd work out the B, or, and add up your values.